Then we'll have different concepts. We have the concept of spatial resolution, which is what is the pixel in your image. So let's see an example, so we don't talk about so much about theory. I'm going to start a existing project that uses remote sensing data. You'll see that during the course you'll be able to work with sample data and your own farm data, either on GeoArgo-GIS or on your own GIS farm software. So basically, when we talk about resolution, we have, in this example, we have aerial imagery, which is between 0.2 and 1 meter, or maybe less than or half a foot and 3 feet. And on top of that, there's a 30-meter resolution normalized differential vegetation index, which, as we just talked in that formula where we're mixing bands that are captured by the satellite, we're seeing low vegetation activity in this range from 0 to 0.3, and high activity from 0.75 to 1, from red to green, classified as you can see on the left. So here we have an idea of spatial resolution, which is pretty obvious, but it's always good to see it. Then you have a spectral resolution. You can have as many as determined by the sensors. You have number of bands and the wavelength width of each band. So we'll see different satellite systems will have different number of bands. You have radiometric resolution, which is the sensitivity of remote sensing to variations. And temporal resolution is how often does your system acquire data. So this will be important for your applications. And these are just some examples. For instance, we use Landsat a lot, which has 30 meters spatial resolution every 16 days, has from 5 to 7 bands. It has a swath width, which is what width does the satellite cover, around 185 kilometers. You have very high resolution, such as Iconus 1 meter. When we talk about panchromatic, it's black and white and the in-betweens. And when you talk about multispectral, you're simply talking about several bands, or more than 3 bands. Because, as you remember, we're talking about the electromagnetic spectrum. So multispectral, it's that you have a number of bands. So this is just to give you an idea. You have different satellite systems. One that's being specialized in agriculture, it's RapidEye, with I believe it's 5 bands and 5 meters spatial resolution. And here you have a minimum order area, so really it's not so applicable to swath width. And you can also have aerial or unmanned aerial vehicles systems mounted on unmanned aerial vehicles. That's coming up in the next years. That will of course, will be based on local requests. Doesn't have a swath width, and number of bands may vary. So 5 to 7 is a typical number of bands, and depending on the height, you could have finer resolution up to 20 centimeters, less than a foot, up to 1 meter. And again, the temporal resolution could be upon request. So we'll see when you identify a satellite, a system with which you're going to acquire multispectral data, you will be asking for these basic characteristics. So that's how you can compare systems.